We're going to start our discussion of energy transfer by doing an energy transfer diagram. We're also going to specifically talk about a falling basketball. So a falling object is a good thing to start with because the energy transfer is fairly simple. It's gravitational potential energy turning into motion kinetic energy. So what we need to do is be able to have a symbol for both of those things. So gravitational potential energy, notice this word potential, stored energy, we're going to represent with a capital G. Motion kinetic energy, note the kinetic, that has to do with the movement of an object, in this case the basketball, and that we're going to represent with a capital M. So our basketball starts at a certain height, starts at the top, then goes about a third of the way down, then goes another third of the way down until it then just gets to right before it hits the ground. So the way we're going to represent our energy is we start with 6 G's for gravitational energy. As the ball falls, the G's turn into M's. So about a third of the way down, still have 4 G's, but then we have 2 M's. And then 2/3 of the way down, we have now 4 M's and still 2 G's because it hasn't quite completely fallen to the ground. But as it gets to the ground, all of our G's have now become M's and we all have motion energy. So let's write this down. Let's put this in words so that we can refer to it, so that we can understand it, so that we can explain it more in depth. So we have that the basketball starts from rest with all gravitational potential energy. Represented by 6 G's. As the basketball falls, the G's become motion energy, or M's. A third of the way down, the energy diagram shows 4 G's and 2 M's. Two-thirds down, there are 2 G's and 4 M's. As the basketball hits the ground, there is all motion energy. Motion energy represented by 6 m's.